Hi, Mom. No, I do not want to greet the world. I hate this phone.
Wish your phone didn't suck so much.
Oh, hi there. I'm just shaving with my G1. So, as you can tell, the G1 makes you connected, smarter, and funner. Funner sounds like a cool word. Anyways, why is that? Let's take a look at some of the applications that make it so great.
Be your personal caddy.
Or
This cab for me from the Android marketplace. You can call cabs. Let's see, where am I? Right here? Yep, here it comes.
Excuse me, sir, did you call a taxi?
Yeah, how much you charge per mile?
I charge $2 per mile. I accept credit, cash, and dog.
Dog?
And dog.
Good.
You want to hop in?
I suppose so. With Google Maps, you can search for restaurants. Let's see, we're gonna go to McDonald's. McDonald's. Man, it says it's rates. Oh, okay, we're at McDonald's. Predict hurricanes? And cook your hot dogs for you. Thanks, G1. Cooked to perfection.
Keep track of how much money you're losing in the stock market? Yep, another 50% today. So there you have it. It's a lot better than your normal standard phone, and the applications are great. Now I'm going to pass it to this guy. He knows a little bit about the system architecture.
I'm an engineer on the Android development team. Android is an open software platform for mobile development. It is intended to be a complete stack that includes everything from the operating system through middleware and up through applications. In the next few minutes, I'm going to be introducing you to an overview of the architecture of the Android platform, and I'm also going to talk about some of the key principles that are underlying its design. If we're going to talk about architecture, we need to start with a diagram covered with a lot of little boxes, and this is ours. Our architecture, we're going to start at the bottom and work up. Our architecture is based on the Linux 2.6 kernel. We use the Linux kernel as our hardware abstraction layer. Our native libraries, everything that you see here in green is written in C and C++. It's at this level where a lot of the core power of the Android platform comes from. Next is the Android runtime, and the main component in the Android runtime is the Dalvik virtual machine. The Android runtime was designed specifically for Android to meet the needs of running in an embedded environment where you have limited battery, limited memory, limited CPU. The Dalvik virtual machine runs something called dexfiles.dex, and these are byte codes that are the results of converting at build time .class and .jar files. So these files, when they are converted to .dex, become a much more efficient bytecode that can run very well on small processors. They use memory very efficiently. The data structures are designed to be shared across processes whenever possible, and it uses a highly CPU-optimized bytecode interpreter. The end result of that is that it's possible to have multiple instances of the Dalvik virtual machine running on the device at the same time, one in each of several processes. And we'll see why that's important a little bit later on. The next level up from that is the core libraries. This is in blue, meaning that it's written in the Java programming language. And the core library contains all of the collection classes, utilities, I/O, all the utilities and tools that you've come to expect to use. Moving up again, we now have the application framework. This is all written in the Java programming language. And the application framework is the toolkit that all applications use. These applications include the ones that come with the phone, like the home application or the phone application. It includes applications written by Google, and it includes applications that will be written by you. So all applications use the same framework and the same APIs. And the final layer on top is applications. This is where all the applications get written. It includes the home application, the contacts application, the browser, your applications. And everything at this layer is, again, using the same application framework provided by the layers below.
This was a triumph. I'm making a note here, huge success. It's hard to overstate my satisfaction. Aperture science. We do what we must because we can. For the good of all of us, except the ones who are dead. But there's no sense crying over every mistake. You just keep on trying till you run out of cake. And the science gets done and you make a neat gun for the people who are still alive. I'm not even angry. I'm being so sincere right now. Even though you broke my heart and killed me and tore me to pieces and threw every piece into a fire. As they burned, it hurt because I was so happy for you. Now these points of data make a beautiful line, and we're out of data, we're releasing on time. So I'm glad I got burned. Think of all the things we learned for the people who are still alive. Go ahead and leave me. I think I prefer to stay inside. Maybe you'll find someone else to help you. Maybe Black Mesa. That was a joke.